In this video, we're going to take a look at the mean and variance of a geometric distribution. In the previous video, we had a look at an introduction to the geometric distribution and how we calculate probabilities for the geometric distribution. And what we're going to do in this video is build on that and take a look at how we now calculate the mean and variance of a geometrically distributed random variable. So to begin with here, let's say we have a random variable x, which follows a geometric distribution with parameter p. For x here, which follows a geometric distribution, like we said, it has parameter p. So for the mean here, so for the mean of this random variable x, which follows a geometric distribution with parameter p, let's just write this down in full. So for the mean of x, random variable x here, well, this would be the same as the expectation of that random variable. It would be e of x, and we can use the Greek letter mu here to represent the mean. So mu for the mean. And this is equal then to 1 divided by p, or 1 over p. Okay, so our parameter p there, the mean is 1 divided by p. That's for the mean of this random variable, which follows a geometric distribution with parameter p. What about the variance now? So for the variance of x here, again, let's just write this down in full. So for the variance of x here, well, that would be var x, using our Greek letters again, this would be sigma squared, represent the variance, so sigma squared. In this case, what I get here is 1 minus p all over p squared. Okay, so those are the two results that we need here. It is important to state here that these are given in the formula book, so you don't have to worry about memorizing these results. But I don't think they're, again, too challenging to remember. So for the mean, 1 over p. For the variance, then 1 minus p divided by p squared. Okay, so like I said, in the formula book, don't worry about memorizing those, but nothing too challenging to actually memorize there. Okay, that gives everything that we need there for our introduction to the mean and variance of a geometric distribution. Let's take a look at some practice questions now for the mean and variance of a geometric distribution. Starting off with question 1 here then, where we've got the random variable x, which follows a geometric distribution such that x is geometrically distributed with parameter of 0.25. We've got two parts here, part A and part B. So in part A, we simply have to find the expectation of x. So in other words, we're looking for the mean of this geometrically distributed random variable. So for part A then, for the mean here, just using the results that we established at the beginning of this video, for the mean then, same as the expectation of x. This is equal to 1 over p. Okay, so 1 divided by p. So in this case here, my parameter p is 0.25. So therefore, p is equal 0.25. So for the mean in this case then, or the expectation of x, simply equal to 1 divided by p, which is 0.25. 1 divided by 0.25. So 1 divided by a quarter. 1 divided by a quarter. If you divide by a quarter here, it's the same as times it by 4. So 1 times by 4, that would give me 4 there. Okay, so that's the expectation of that random variable there, x, giving us 4. So for part B then, we're now looking for the variance of this random variable x. So we're looking for the variance of x. So again, the result here that we need, this would be 1 minus p all over p squared. Okay, we know what p is, that's 0.25. So I've got 1 minus 0.25. Then we divide this here by 0.25 squared. So 1 minus 0.25, that would be 0.75. This would be over 0.25, so that's 1 over 4. So if you square that, that would be 1 over 16. 1 over 16 there in the denominator. Obviously, what you could do is just put this into your calculator. If not, if you're doing this by hand, this would be the same as 0.75 times by 16, because we're dividing by 1 over 16. And in that case then, 0.75 times by 16 that would give us 12 there. Okay, but like I said, absolutely fine to just throw that into your calculator there. Either way, like I said, you could get 12 for the variance. Okay, so let me just write that down here. Okay, so the variance of the random variable x there is 12. And there we have it. So that's the solution there to question 1. Moving on to question 2 now, where we have the geometrically distributed random variable x, which has parameter of p here. Now we're told here that this has the expectation of x being 2.5. So for this random variable x, we know the mean, in other words, is 2.5. So again, 2 parts here. For the first part, we're simply looking for the value of p. Okay, so we want to find the value of our parameter here. So how do we do that? Well, because I know the value of the mean here, or the expectation of x, we can use the result then for the expectation of this random variable x because it follows a geometric distribution. So for part A then, like we said, for the mean here, or in other words, the expectation of x, we know this result is 1 over p, okay, because this follows a geometric distribution. So it's 1 divided by p, but we know what the expectation of x is equal to. It's 2.5. So in this case here, I can take 1 over p, set that equal to 2.5, and then solve for p. Okay, so like you can see, it's not actually too challenging here. Like we said then, we've got 1 over p, and that's equal to 2.5. So I now multiply both sides here by p, get 1 is equal to 2.5p. And then finally, divide both sides now by 2.5, therefore p is equal to 1 over 2.5. And 1 over 2.5 here, that would give us 0.4. Okay, so I get 0.4 there. And there we have it. So that's the value of p there, giving us a solution to part A. So now we move on to part B here. We're now looking for the standard deviation of the random variable x. So we know what the parameter p here is, that's 0.4. Our distribution here is x follows a geometric distribution with parameter 0.4. If we want the standard deviation of this random variable x, what I need to do to begin with is find the variance. So for the variance of x here, Rx, remember our result here, and don't forget these are in the formula, but you don't have to worry about memorizing them. But just in case you forgot, this is 1 minus p all over p squared. Okay, and we know p is 0.4. In this case here, this would be 1 minus 0.4. We then divide that by 0.4 squared. 0.4 squared there. So all you need to do is just put this into your calculator. If you do this correctly, what you should get here is 3.75. You'll get 3.75 here for the variance of x. Remember, we need the standard deviation. So we're not done here. This isn't our solution. We want the standard deviation. Remember, the standard deviation is equal to the square root of the variance. Okay, so let's just write this down here. Standard deviation is equal to the square root of the variance of x. In that case here, we're going to take the square root of 3.75. Square root of 3.75 here. And if we just give our answer to a sensible degree of accuracy here, let's say 3 significant figures, what I'm going to get then is 1.94. Okay. 1.94 there, 2 3 significant figures. Okay. And there we have it. So that's the solution there to question 2. And finally then, if we take a look now at the very last question here, question 3, where we have the probability of Tom hitting the bullseye whilst playing darts, and that's given as 0.125. Now we also have the random variable x here, which represents the number of throws needed until Tom hits the bullseye. So for the first part here, part A, so let's just write this down. We're asked to state a suitable probability distribution for x. So remember x here, that's the random variable x, which represents a number of throws needed until Tom hits the bullseye. So for this question here, based on the context of the question, x will be geometrically distributed. Let's just write that down to begin with. X follows a geometric distribution. So all that's left to do here now is just state the value of the parameter p. So because we're looking at the number of throws needed until Tom hits the bullseye, but we do already know the probability of Tom hitting the bullseye. That probability is 0.125. So my parameter P here is simply that value. It's 0.125. Okay, so we just put that down here, 0.125 there. Okay, and there we have it. So that's the solution to A. That's our suitable probability distribution there for X. Moving on to B now. We're asked to find the mean and variance of the random variable X. So for the mean, that's the same as the Greek letter mu here. So just remember, all we're using here is the results that we established at the beginning of this video. So the mean would be 1 over P, where P in this case is 0.125. It's going to be 1 divided by 0.125, which is the same as 1 over 8. Same as 1 divided by 1 over 8. And if you divide by 1 over 8, it's the same as just timesing by 8. So 1 times by 8 would give us 8 there. Okay. The mean of X is equal to 8. We now also need the variance of X. So the variance here, that would be sigma squared. And again, we're just simply using the results that we established at the beginning of this video. So in this case, this would be 1 minus P, then we divide this here by P squared. Okay, so 1 minus P here, so that's going to be 1 minus 0.125. Then we divide this here by 0.125 squared. What you need to do now is just simply put this into your calculator here. And if you do that correctly, what you should get here is 56. Okay, so the variance here is equal to 56. And there we have it. So that's the solution to question 3. That brings the end of this video on the mean and variance of a geometric distribution.